Hi everybody, this is Caitlin, and this is my presentation on permafrost and climate change, looking at thermokarst processes on Alaska's North Slope. So permafrost is defined as ground that stays frozen for 2 or more years. It can be frozen for much longer, even hundreds and thousands of years. It is found mostly at high latitudes, so near the Arctic and the Antarctic, but it can also be found in mountains at high elevations. Permafrost comprises an entire quarter of the landmass in the northern hemisphere, and it determines a lot about the landscape, from topography to hydrology to soil conditions, the type of vegetation that can grow, etc. In addition to the carbon, thawing of permafrost can cause a lot of damage to infrastructure. As the ice within the permafrost disappears, it loses its stability and can collapse in on itself, causing slumps and the development of thermokarst terrain. So thermokarst forms when permafrost thaws, which increases the active layer thickness. The active layer is the layer of soil on top of the permafrost that freezes and thaws seasonally, so it's not permanently frozen. And with increased active layer thickness, the thawed soil collapses in on itself since it no longer has the structure of the frozen ice. This is a natural process that happens, but it can also be caused by climate forcing with the warming, and it can be a sign that the underlying permafrost is degrading. Here are a number of different examples of different thermokarst forms. Of course, we have the thermokarst lake. There's also thaw slumps. There's gullies that develop and ponds. So there's a whole range of different terrain and reactions you can get due to thermokarst development. Then here we have a short walkthrough of the process of how a thermokarst lake might form from permafrost that's degrading due to climate change. And then here is a diagram of the thermokarst lake. This one shows it taking place over hundreds of years, but of course, as the climate warms, this process goes quicker and quicker. But it gives you a nice little visual idea of how it's working underground with the thawing of the permafrost. And on the right here, we have the Landsat image of part of the study area. You can see the numerous thermokarst lakes, which are all oriented parallel to each other. This happens because the lakes tend to orient themselves perpendicular to the direction of the wind, with the way that the wind sort of generates the water patterns, which cause erosion, and it creates these long oval lakes, which are all in line with each other. Within my study area is the one urban area of Barrow, Alaska, which I believe the name you pronounce it now is Utqiagvik, and I'm probably saying that wrong. But part of the reason I picked this area is that this town has been a site for climate research basically for decades now. It's the northernmost town in the United States, so they do a lot of Arctic research, and they also, track the climate there too. So for my project, I was interested in detecting changes in the permafrost around the North Slope of Alaska. Unfortunately, permafrost is one of those things that is difficult to detect using Landsat and other satellite data because it is underground. So instead, there's a number of sort of proxies that are used to sort of infer things about the condition of the permafrost. And as it says in the slide here, some of them are surface temperature, topography, vegetation cover, surface moisture, changes in especially like vegetation and moisture can indicate changes in the underlying permafrost, whether it is thawing and so the soil is becoming wetter, and so forth. So here is the Landsat 8 image, which I adjusted to try and detect soil moisture, where darker areas should indicate areas of higher moisture. As you can see, it shows the lakes and the water very, very well, but the soil looks pretty uniform for the most part, which would indicate there isn't a lot of difference in vegetation or soil moisture over this area. So these are the NDVI vegetation indexes for the Landsat 7 and Landsat 8 image. There is not an enormous amount of difference between them when we use the difference function, indicating that the plant life in the area was probably fairly uniform for the period between the Landsat 7 and the Landsat 8 image. And this is the land use classification with 5 classes. The Landsat 7 image is at the top and the Landsat 8 is at the bottom. And so when I went through and reclassified my thing into 5 classes, I got water and ice for very obvious ones. Then some of the colored ones, I have the green is marsh because I figured it should be soil that's like somewhat wet. And then as far as purple and orange go, I'm not entirely sure. There's some type of ground that is drier, I'm guessing, but I'm not sure what distinction to make between those. But as you can see, the Landsat 8 image has much more green on it, so it would be like indicating that's wetter, I guess. And so here is the change in land use image that was made by finding the difference in the last 2 images. The reason I have 2, the one on the left included the lake ice coverage, which naturally is going to change from year to year, so it was classifying that as a change. So I went back and recategorized things and made the water and the ice one category so that there would be no change detected for having different ice in the lakes. Unfortunately, there aren't any real strong patterns for change or no change in either of them. Yeah. So using the various things in ArcGIS, I wasn't able to come or to find any definitive changes in the thermokarst in Alaska that would indicate any sort of change in the permafrost condition. And I think this is because the resolution was too far out. The images were just too big. So I was looking at Google Earth, where you can of course zoom in much more, and in these images you can even see some of the finer the finer permafrost structures like the polygons. In the bottom image you can see where the ice wedge polygons are actually breaking apart and melting a bit. So having detail like that and studying that probably would have been more fruitful than looking at a much larger area, which is what I did.